Hey guys, so what we're going to do today is we're going to look at how we can convert a quadratic equation from standard form into vertex form. And we do this by completing the square. And you're going to do a lot of this next year in geometry and a lot in Algebra 2 trig. So it's an important process to understand how to do it. There are easier ways, but this is another way. I just want to show you that algebraic way. Okay, but before we do that, I just want to go over standard form. Remember, is ax squared plus bx plus c. And vertex form, we've been looking at it, but we haven't really touched on it. So vertex form is a times x minus h squared plus k. And we're going to get into that. The h and k are our vertex, and that a is just the number in front of x squared. That's either going to flip the quadratic or make it more narrow or wider. So that, just remember, that's what that a does to the quadratic. All right, so before we can do that, I just want to let you guys know that in order to do right from standard form to vertex form, you need to remember how to complete this square, okay? So let's just go through this one time just to refresh our memory. With completing the square, we need to make sure our x terms are isolated, which means we have to move that constant over so we can make that perfect square trinomial. So in order to do that, we want to rewrite our x terms with plus a square equals negative 16 plus a square, okay? Now what do we have to do? We have to take b, have it, and then square it. Well, b is 12. When we have 12, we get 6. That's the number in our factor. When we take 6 and square it, we get 36. So 36 is the number that's going to go into our square. Now we clean it up. We get x squared plus 12x plus 36 equals negative 16 plus 36 is 20. All right, and now what we do next is we factor that polynomial or trinomial, which we don't have to worry about the factors because we already told you it was going to be x plus 6, x plus 6. That number is the number that goes in those factors, equals 20. Now we write it with that little squared sign, becomes a perfect square, equals 20. And then in order to solve it, we have to square root both sides. That allows that x plus 6 to come out of the parentheses. And we bring down that 20 as a plus minus 20. Radical 20, sorry. Now what do? We have to solve for x. How do we get x by itself? Well, we subtract 6 from both sides. So we're going to subtract 6 here, subtract 6 here. And you're left with x equals negative 6 plus or minus the square root of 20. Okay? So you could set it, you could plug in your calculator. You can simplify it in simplest radical form. I just needed you guys to go through the steps. Okay? So make sure you pause the video and get this down. Now let's look at vertex form. So we already talked about what vertex form is. Now in vertex form, the number in front of, not the number in front. This number here, the h is the x in the vertex, and that number k is the k in your vertex. Now, when you plug it in your equation, and I'm going to, this number is the opposite of what the x is. So when you take it out to get your vertex, you'll notice it goes from negative h to positive h, and the k stays the same. So it's really important when you're trying to find the vertex of a quadratic in vertex form that you know to do that. So for the first one, the vertex is going to be 2, 7. Now you could plug this in your calculator and go to your table and prove it, that the actual vertex, the turning point, is 2, 7. Again, this number is negative 2, so it gets pulled out as the opposite, and then that number stays the same. The vertex for number 2, well, this number gets pulled out as the opposite, so it's 6, and then this number stays the same, so it's negative 9. So the vertex of that particular function is 6, negative 9. So this is like a lot easier when it's in this form. And now this vertex, that one gets pulled out as its opposite. The opposite of positive 3 is negative 3. And then the 4 stays the same. And therefore, the vertex of number 4 would be, if this 5 gets pulled out as the opposite, it becomes negative 5. And then the negative 1 stays the same. You can always check these in your calculator into your graph, okay? You plug it into y equals and look for that vertex. But this is the simplest way of interpreting this particular form. Do I know what my roots are? No. Do I know what my standard form is? No. But I can tell you what my vertex is. And that's what today's goal is to convert from standard form to vertex form. So we don't have to plug it in our formula. We can actually find the vertex this way. All right? So let's practice one together, and then you guys are going to do some on your own. Okay, so we're still going to do the same thing like we did before. It says you're going to replace the f of x or the y with 0. I don't know why this is a 0 in here. That is just a typo. So first you're going to, so pretend that 0 is not there. You're going to replace the f of x with 0. So again, you're going to complete the square. So in order to do that, we're going to set equal to 0. So I'm going to put the 0 on the left-hand side. I'm sorry, on the right-hand side. So I'm going to do x squared plus 2x minus 1 equals 0. So now what we're going to do is we are going to step 1, isolate our x terms. So we're going to put our 1 over here, and we're going to leave that box there to keep it so we can make a perfect square trinomial. Okay, so now we're going to find b. We're going to have it and square it. Well, b is 2, so I'm going to take 2, have it, and get 1. Then I'm going to take 1, square it, and I also get 1. So that number is going to be the number to go in our square. Okay? Now we're going to clean it up. We have x squared plus 2x plus 1 equals 2. Now we factor. And remember, we don't really need to factor because that number is up here, that 1. X plus 1 equals 2. Now we write it as a perfect square. X plus 1 squared equals 2. Now this is where you stop. This is where it gets different. This is step 6. What we're going to do is we're going to move this number over to the left. And we're going to get x plus 1 squared minus 2, because it's positive to get it to the other side of the equal sign, equals 0. And then all I have to do is replace that with an f of x. And now I have it in vertex form. Now, test yourself. Can you tell me what the vertex of this parabola is? Remember what we did before. This number gets pulled out as the opposite, so it would be -1, and the -2 stays the same. So the vertex of this particular quadratic would be -1, -2. So that's it. It's just completing the square to change from standard form to vertex form. Okay, and again, like I said, this is an important skill that they want you to be able to do on the region. So pause the video, make sure you get this down. So I just want you to try the next 2 practice problems. Make sure you get your answers right. Look at the key. If you didn't, please make sure that you go over the videos that I posted. Then you have a delta math. There's 4 examples that you're just going to go from standard form to vertex form. Okay, just remember, do your workout on paper first and then plug your answers in. And make sure you follow the directions on delta math on how you're plugging things in. If you have any questions, just don't forget to contact me. Have a great day, guys.